Alrighty, Good morning, everyone. Thank you for attending this session. My name is Hector Linares. I'm a program manager with the Virtual Machine Manager team. And today we'll be talking about common storage scenarios that you can enable through VMM SP1. Just a few rules for today. I tend to talk fast as a New Yorker, and so if you guys need me to slow down, just let me know, and I'll do that, no problem. I'm going to be walking around a lot because these lights are a little too bright. And so you'll probably see me walk through the stage. But if you have any questions, if I don't see you at the end of the session, feel free to come up to the mic. This is a 300-level session, and so a lot of my demos are PowerShell-based in working with VMM. Everything you can do, you'll be seeing in these PowerShell demos, I'm going to post on a blog, or they're also going to be in this slide deck. So in case the network goes out, at least I'll be able to walk through the script and give you a general idea of what I'm demoing. Alrighty, so let's get started. And I want to start off first by talking about some of the pain points that we heard from all of you around storage management, and really some of the little bit of a history as to why we're even doing storage management in Virtual Machine Manager. Now, how many of you are actually deploying VMM today or have used VMM? Great, good number. And from the storage integration piece, how many of you are actually using the storage management, working with the providers and working with partners? Okay, good. So this is going to be a good deep level session on storage. So there's going to be some assumptions on storage management and what devices are, arrays, pools, LUNs. I do have a demo at the end around fabric management, so fiber channel switches, getting fabrics, getting zones, activating zone sets, and adding members. Okay, so one of the common complaints we heard from customers working with their storage arrays, working with storage in general, is that there's a lot of wait time before something actually gets provisioned. And that's usually due to either corporate policy on SLAs on how long certain operations take, or in general, there's just a lot of backlog with the different administrators, so things don't happen on demand. And for those customers that actually started looking at some automation to get around that problem, what they hit was a lot of APIs, a lot of different interfaces that you probably don't have the experience around coding this or having that kind of time to do it. So with the lack of expertise, that actually stopped a lot of customers from automating. The ones that actually did go as far as trying something, they hit a lot of APIs as well, and each API was a little bit different that made it even more difficult. And for those that actually went as far as doing some automation, really what they were looking for is that human error piece, getting rid of the human error, getting a LUN unmasked to the wrong IQN, getting a worldwide port name put into the wrong zone, or the wrong port name into the right zone. We also heard from a lot of our partners as well, once we started going down this path around storage automation and storage management, in that the reverse problem started happening or started surfacing. With Hyper-V becoming very popular, partners were now looking at ways of pulling all the rich data from VMM into the partner consoles. So if you're going into, for example, fabric management, you could see all the hosts and the VMs and everything that's attached to a switch, as opposed to just a worldwide port name. So partners started embracing a lot of the end-to-end mapping and discovery that we were doing, and now they want to pull that data out. Another ask from partners is to really figure out how do we streamline all these APIs, right? So that all partners are getting different asks for REST interfaces, PowerShell, CLI, and all these other things. So one of the things I'll talk about is how through Windows Server 2012 and SM API, or the Storage Management API, you can actually get WMI, PowerShell, and even REST endpoints as part of the platform. So a little bit more history on where we've been and where we are now. So VMM has always had some level of storage automation and storage management. Between 2007 and 2008 R2 SP1, we did some work with VDS hardware providers to be able to discover a storage system, and really we only did masking and unmasking as part of SAN transfer. In 2012, we actually upgraded and went to SMIS, and so that's when we started doing a lot more deep end-to-end discovery, LUN creation, LUN deletion, snapshot, cloning, masking and unmasking. And now in 2012 SP1, we've switched over to Windows Server 2012 Storage Management API, which is now a native API in Windows. So previous to Windows Server 2012, the only way that you can get these advanced storage features was with VMM. So now with Server 2012, you get that inbox. And so now you can plug in your providers into SM API and light up all these cool features. So to give some perspective as to the feedback that we're getting, and I'd love to get the feedback from you as well for those that haven't had a chance to use it or haven't. If there's something that's blocking you, would be great to know that as well. But customers that are embracing the private cloud, they love the idea of on-demand everything. For the most part, what we're seeing, a lot of customers and partners producing these racks that are fully integrated, storage, computer, networking. So now the virtualization admins don't have to depend on outside help to get all the, at least outside administrators to get everything they need inside of a rack. But now the question is, how do we get everything done on demand, deployed on demand? So now you got virtual machines that can be created in matters of seconds. How about zoning? How about LUN creation? How about discovery of pools, et cetera? From a partner perspective, they love the fact that with a provider plugging into the platform, they can light up a lot of their cool features, right? So it's software and hardware working better together. And finally, service providers. We do have a big focus on hosters and service providers, and what they're seeing is that our capabilities, really along System Center as a whole, match what they're doing in-house, right? So the more that they can offload to software they can buy, they can really worry about the value add that you guys build on top. So 3 main sections to storage management. Okay. 3 main sections to storage management. First, we talk about insight. So it's really the first thing we did with these providers is that we go out and figure out what's out there. And so we use the providers to communicate to the arrays, to the NAS devices, and pull in all the rich information that we would need, and then to stitch together with Hyper-V, any LUNs or file shares that are in use by Hyper-V. And so that's end-to-end mapping. That's the first piece. We lay the foundation to build everything else we do. From a storage classification perspective, we want to give you an easy way of deploying to gold, silver, bronze storage, depending on whatever SLA or performance guarantee that you have with your storage admins. And so you can classify your pools inside of VMM as gold, silver, and bronze, and deploy, and especially for cloud users, they don't need to know which array, they don't need to know a LUN, they just need to have a template that needs gold storage, and then they can deploy to a cloud. How many of you are actually deploying to VMM clouds or using the self-service modules of VMM? Okay, so VMM has the ability to abstract capacity into a cloud, and then you can present those clouds to your end users. So they never need to know about the underlying fabric or compute, storage, and network. They just need to know about the resources that they can consume. We're doing a lot of this through standards-based management, and so we are, Microsoft as a whole and Windows Server is adopting a lot of standards-based management. This is one of the areas where we're using these standards to manage a wide number of devices, both across block and file. So now that we've laid that foundation and that platform, we get into the flexibility of what you can do with VMM. Like I mentioned before, we do have block and file management. By that I mean we can discover fiber channel, iSCSI, SAS devices. We can automate against those devices. We also import NAS devices, so a NetApp or EMC. We can bring those under management, and also Windows file servers. So Windows Server 2012 scale-out file servers are also managed through VMM SP1. So we give you that flexibility of being able to manage all those different types of storage devices. We've worked hard with all our partners to make sure that whatever you can do with VMM, you can do it at scale. Obviously, that's very important when you're deploying in a large data center. So we've done all the work to ensure that the providers work, that SM API works at scale, and VMM as well. Towards the end of the slide, I'll show you a pretty extensive list of all the partners that we've worked with and where they are in validation level. And if there's any partner that you don't see on the list that you'd like to see, obviously please do let us know. They might be in the room, so that always helps as well to show the interest. Allocation assignment. Since everything is coming through VMM, we've built all the UI in PowerShell as well to add storage capacity from a host and cluster and VM perspective. So you don't have to jump out to the different consoles, and so you got a lot of flexibility within VMM. And the final piece is automation. So we got the flexibility of everything we can do, and then automation brings in the end-to-end workflows, right? So we're not using Orchestrator in VMM natively. Show of hands of Orchestrator users. Excellent. All right, so just to let you know, all the workflows that I talk about here are embedded in VMM. They're not extending orchestrator workflows. But the idea is that we basically go from, position A to D, and we automate that whole line of workflows, whether it's LUN creation to unmasking to mounting, partitioning, formatting, all of that. We automate some of the array onboarding, so if you have a nice SCSI array, you can bring that into management, and we will log into the targets. If it's a static target array, if it's a dynamic target array, we'll just bring in the portals, so an EqualLogic or a Microsoft iSCSI target. Like I mentioned before, we do storage management for VMs, hosts, and clusters. And finally, one of the demos I'll show you is around rapid provisioning. So the idea is that once you provision a VM using the capabilities of the SAN, you want to keep the VHDs on the SAN. So we enable SAN migration so you can move VMs from host to host with a simple masking and unmasking operation. So at a high level, the architecture that we have in SP1, I'm not going to show previous versions. Obviously, we're just talking about SP1, but there's other presentations that we've done in the past that show you our previous architecture. But now with Server 2012, like I mentioned before, we have this storage management API. Now, the storage management API is that interface to the underlying storage devices. That is the way that we can abstract a lot of the variations when it comes to the simple provisioning operations and actually have a wide range of partners that we can work with through this common API. Underneath Storage Management API, you've got three provider models. The first one is the storage service, which is the SymXML-based, and let me take it back. The SMIS service that talks to SMIS providers. And so this is a feature that ships in-box with Windows Server, and if you go to the features list, it'll be under Windows Standards-Based Management. You enable that feature, and then you can add SMIS providers. We also have partners building native SMP providers that plug in directly into SMAPI. Functionality is the same, so partners, regardless of the path that they choose, they can show off all their capabilities through SMAPI. And finally, there's storage spaces, which is a new component of Windows Server. And so that's, how many of you have actually used spaces or know of the technology? Okay. Just at high level, it's the ability for Windows to group together a bunch of physical disks into a pool and then create virtual disks, or what we commonly talk to them as LUNs, from those pools. So the virtual disk can then be used and attached locally, and then, especially in the file server case, can be presented as shared storage where you can have a scale-out file server with a scale-out file share. So that technology today, just so you know, is not managed by VMM. It's part of the platform, but there's nothing that we do in SP1 around storage spaces. So the different types of providers, just if we explode this out, I'm going to start from this side here. SMIS providers come in different flavors, so there can be an embedded provider that sits on the NAS, on the storage device itself, no additional servers required. We do have support for NAS proxy providers. A proxy provider is essentially another machine that sits on a network where VMM communicates to this machine, and then the proxy provider communicates to the NAS device. We do have support for providers that support both SAN and NAS, and this would be the NetApp case that supports block and file in the same provider, and also just typical SAN proxy providers that are just exposing block storage. The SMP providers, so none of these providers that are proxy for the SMI side actually need to be installed on VMM. We actually recommend that you install them on other servers. Now, the SMP providers, those actually have to be installed on the same server as VMM. So we've been working with EqualLogic and Nexan, who support SMP, and these providers actually get installed on the box itself, on the VMM server itself. And then Spaces, like I said, it's there, but today we're not leveraging them. And then Windows scale-out file servers, we actually talk directly to the WMIV2 interfaces on Windows for Windows file servers, so there's no additional proxy in this case. It's really just the interfaces available there. That interface or that communication channel does not go through SMAPI. That's a separate channel that we have to work through. But we're trying to abstract as much as we can and simplify the environment. Okay. So let's jump into a demo. The way I'll set this up is around over provisioning and thin provisioning. How many of you actually use thin provisioning or know of it? Okay. So there's two flavors of this. First, thin provisioning that can be done on the storage array itself, where really you're You've got some physical capacity. The number of physical spindles, you're bound by physics. That's how much you can actually store on the machine, on the device. So, you create LUNs, and those LUNs get presented as disks, and Windows says, I've got 10 terabytes. Good, and everybody's happy, and you put NTFS or REFS, and then you start using the file system. Obviously, you can overpromise, right? And then you've got more capacity than that you physically have. And so these disks are getting used. At some point, and this is a rough sketch, but these are to scale. So at some point, only one of these has to trigger, go outside what's physically available before that pool can no longer actually write any more data. So typical use of thin provisioning is that you've got an array with X amount of capacity, but you've got a lot of workloads, and you take some measurements on how over-provision you can tolerate, whether it's 200% or 300%. So the question is, how do you know? How do you know how over-provisioned you are? So let me jump to first. Oops. Okay. So first, let me show you the integration that we've done with Operations Manager. So I'm going to jump first into the VMM console. So in VMM, we've got workspaces down here, VMs and services, fabrics. I'll mostly be between these two workspaces for this demo, for this session. So if I click on the Fabric workspace and I go to providers, these are the list of providers that I've got added to this VMM instance. And so these are, like I said, these are the ones that give us all the rich information from the devices. So if I go to Add Resources, Storage Devices, and there's the three types that I mentioned before. There's Windows File Servers, SMIS, and SMP. I'm going to click on the SMIS one for now. And basically, you would choose your protocol. Most SMIS providers are SymXML today. You would type in the address. In this case, I'm just going to pick one that I already have. And you go off on Discover. Now, when we discover, we do a level 0, level 1 discovery. All that basically means is that we get the top-level computer system or the storage device, and then we go off and get the pools. That's the simple information that we get, which is the first level here. And then the second level, in this case, this is a NAS and SAN provider, so it gives us both block and file. So I've got several pools here, and I can essentially pick one pool and assign it to some storage. Assign a classification, and when I hit next to finish this wizard, now we'll do a level 2 discovery. We're going to go off and for the pools that we've selected, we're going to get all the LUNs. In addition to all the LUNs, we're going to get all the masking sets. Masking sets are used to expose a LUN through a set of targets to a set of initiators. That's how you present the LUN to a host. And we'll get all the masking sets, all the LUNs, all the initiator ports, all the target ports. In the iSCSI case, we'll get portals as well. And yes. Okay. So I'm not going to do this. It takes a little bit of time. But essentially, once you have a pool under management, you can go to, I clicked on classification and pools. Let me extend this a little bit. I clicked under storage, classification, and pools. And then I've got my pools that are managed. So I can extend, for example, this iSCSI target pool and see all the LUNs that are there. And one of the things we can also do is figure out if a particular LUN is assigned. Right? So is there a masking set that essentially says this LUN is exposed to another host? And so in this case, this one is. Let me bring this up a little bit. Oops. Sorry, this is not the. There we go. That's the one I want to click on. So I've got this. Well, I've got the host under management. The reason why the other one didn't show a host is because I don't have whatever host that is exposed to. I don't have it under management, so I don't know the IQNs or the worldwide port names. In this case, this host N3, I've got it under management, under VMM management, so I can show the list. If it was a cluster, you'd see all the nodes in the cluster as well. Okay, so one of the things that we show here as well for this particular LUN is that it's, we're signaling that it's over-provisioned. And this is essentially based on the fact that we know that there's a VM deployed and that there's a dynamic disk that exceeds the size of the LUN, size of the LUN. And just the last piece here to show you. So, and then you can see all the arrays as well that are managed by System Center. We do have more partners than this list, but these are the ones that I have in the lab, so that's what I was able to add. Okay, so what I'm going to do now is I'm going to switch over to the demo itself. So the first demo I'm going to show off is for a pool. I want to find out all of the LUNs that are provisioned on a pool, and especially if they're thin LUNs, I want to find out what my overallocation is. So like I said before, I'll post these online, just high level. Basically, through VMM, I can get all of the storage pools. Right, so that just pulls every pool that I have under management. For every pool that's under management, I'm going to get the list of LUNs, and then I'm going to iterate through that list of LUNs and figure out the total size by taking the total capacity, essentially just adding that up, and then I'm going to calculate the over-provisioned piece. So what this script does, it walks through that, iterates through all of that, and what it should pop up at the end is a very rudimentary report. But the point here is that now you can figure out at a quick glance which one of your pools that are managed. If it's not managed, maybe not as interesting, but at least the ones that are managed, you can see how over-provisioned you are. Now, in this particular case, the reason why this is not a bug, I think it's only 198 gigabytes. I created like 10 4 terabyte LUNs as thin provision, so that's why you see the number so high. Okay, so interesting. It's a good start. Now, what if you wanted to get a little deeper? So at least within provisioning, you can, you can figure out through what are called sense codes if a particular LUN has reached a threshold. Let's say 70%. If the underlying device has reached a 70% threshold on the available capacity, you will get an alert. Now the question is how. So the integration with OM is actually starts in SP1, and what we've done is essentially built an MP that does a discovery of all of the data in VMM. So we're bringing out all of the data that's already in VMM and putting it into the OM space or OM instance space. And so that's how we're able to generate this report. So when a particular LUN or pool goes into an unhealthy state, we will be able to flag that and then actually show you all of the VMs that are impacted by that thin provisioning alert. So if your alert's at 70%, at least you have the idea of who's impacted. You can start migrating VMs that are critical, or you can start adding capacity if you have the additional capacity available to you. So where we don't get alerts, however, and this is the second demo, is actually with dynamic disks. So you can have let's put storage aside for a second. You can have a volume today with a bunch of dynamic disks deployed, and you have the same over-provisioning problem. So with the data in VMM, you can do the same thing. And so what I've essentially done in this script is for all the shares that we know about, I'll do the same total calculation and run through that. And then for all of the disks, and disks in this context, I'm talking about Windows disks. Windows disks that present volumes that then you can use to deploy VMs. I'm going to iterate through all of the disks and then give you the same report back. Okay, so like I said, I've got a bunch of disks out there. Some of them do or don't have actual VMs that I've deployed, but you can essentially see I've cataloged all the VMs on the right-hand side and then shown you the over-provisioning percentage. Now I'm going to pick on this particular volume that's at 400%. So one of the things you could do in VMM is that I'm going to switch back to the console. I'm going to scroll up, and I'm going to click on my H1 host. Sorry, I'm going to click on VMs and services, so I can actually see the VMs. I'm going to click on my N1 host. Sorry, H1 host. Some host. Give me a second here. That ain't it. There we go. Sorry for that little confusion there. Okay, so I've got this particular VM that I know is on that volume. One of the things I could do for this host, and this particular VM is on host. Let me show you that. Yep. So you can see the host that it's on, H1. When I go to H1, I'm going to right-click on it, go to Properties. I'll click on the Storage tab. So here I get to see all the disks, all the arrays. If I had some fiber channel arrays, you could see that as well, or iSCSI. And we'll also show some file shares. So in this case, I've got 3 file shares. One of them is called VJ TE demo. So this was used by VJ in his Monday session at 11 o'clock or 11:30. And so this has already been registered. This is a Windows Server 2003 scale-out file server share that's actually registered to a host. When we say register, what we essentially do is go off and modify all the ACLs on the share and on the file system to make sure that that host and VMM can access the share and do operations. So I've got the share registered. What I'm going to do now is migrate the virtual machine. I'm going to migrate the whole virtual machine within the host simply because I want the config and the VHD to be to travel together. So I'll click H1 in placement. I'll go hit browse, and then in the list you see VJ. Yep, you'll see the file share listed. Again, we know that it's registered, so we can list it there as an available location. And I'm going to essentially place all of the VHDs with that share. So I'm going to let this continue, and then I'll rerun the report to show, basically we'll recalculate this, and what we should see is a drop in the over-provisioning level. Okay, so let me switch back to the ISC, rerun this report. Yep. So now T is down to 200%. So then the question is for you, what's your risk tolerance? Right? It could be 200%, it could be 400%. Some people want to go 100% max and no more than that. So you can actually quickly get all that information through VMM. Okay. So like I said, I backed up all of the demos in the slide. So when I skip through these, I'm not skipping content, I'm just skipping through the demo that otherwise would have been in this format. So I already talked about the SMB 3.0 support. So this includes Windows Server 2012 scale-out file servers, and also file servers or NAS devices coming from partners like NetApp and EMC. Essentially, anybody implementing SMB 3.0 is really going to be the target for Hyper-V as one of the main deployment storage. Okay. So, all we did there is just, we looked at some information that's already in VMM, and we generated reports. How do we get more interesting as far as the automation piece that we can do with VMM? So, like I mentioned before, we do the storage management for Windows servers, Windows Hyper-V, and hosts and clusters. And these are essentially the operations that we support from advanced storage management. After discovery, we can do the share provisioning, LUN provisioning, cloning, snapshots. In SP1, we do now support indications coming up from the provider into the underlying cache. Indications are important because we realize that there are going to be storage admins working with the devices. We do want to have the most recent information in our cache. So we use indications as a way of avoiding like a 30-minute refresh, because those refreshes could take 10 minutes or whatever, depending on the size of the array. So we use indications to get the most up-to-date information from the array itself and the provider. The key highlights here, like in SP1, support for scale-out file servers, for support for NAS devices, support for SAS arrays as well, dynamic iSCSI targets, and assigning of VMs to IQNs explicitly. All right, so now that we've got all these primitives that we can play around with, what's one interesting thing we do with VMM is what's called SAN-based rapid provisioning. And so this is essentially taking the ability of the array to quickly generate or create snapshots of an existing LUN in a matter of seconds. And so we leverage that capability to create new VMs essentially on demand and with zero transfer time. Right? Because in a snapshot case, you're not moving any data. Depending on how efficient the array is, it can actually just create a snapshot in a matter of seconds without any data movement or data copy. So we leverage that as part of one of the bigger workflows around SAN-based rapid provisioning. So we started working with this, and one of the interesting bits of information is that depending on the array, they might have some limit on the number of snapshots per LUN. Okay, some of them 64, others are 256. So we implemented this feature called allocated LUNs, or essentially which are clones of a LUN that you can associate with a template. And so if one LUN can handle 256, 10 LUNs should be able to handle, right, that many more. So instead, when we provision a VM using rapid provisioning, instead of using the original LUN, we actually use all of the associated clones. So those associated LUNs or associated clones are the ones we generate all of the VMs. And so the algorithm essentially exhausts one of the LUNs and it moves on to the next. It doesn't do a round robin, right? This is just what we picked as far as the algorithm. So then how do you light this up, let's say in the VDI scenario? So let me get to the demo screen. Okay, let me just switch over. Okay. So I'm gonna kick off a start demo script right now. So it just and I'll explain every line of the script that we go through. Okay. So the point of the script, we're going to create a VM. We're going to create a LUN. We're going to unmask it to a host. We're going to put the VM on that host, and you can envision that's a Windows 2000, Server 2012, or Windows 8 client, and you get to customize it. And then VMM has a feature called New Template from VM, so we can take the existing VM, sysprep it, and then bring it into the library. The cool difference here is that instead of copying the VHD to the library share, we'll actually mask the LUN from the host and unmask it to the library server. So I'm going to initialize some variables first. Okay. So first I need to create a LUN. So I'm going to get a pool. I'm going to create a new LUN. So this is the new SC storage logical unit. I'll give it the, by template name, it's not the template, it's just the name of the LUN that I'm going to use, the pool that I'm going to carve it out from, and the size. This is going to be a fairly small LUN. It's only one gig, but for demo purposes, it's good enough. Okay, so LUN's created. So now I need to allocate the LUN to a host group. And the reason why we have allocation is essentially gives administrators a way of controlling of all of this capacity that I have. I could have hundreds, thousands of LUNs. Maybe for this virtualization environment, I only want to use a subset. Or more specifically, maybe this particular business unit only needs to have a certain amount of LUNs. I've provisioned the LUNs for them. I want to give it to them. So you can actually assign pools and LUNs to host groups. And that's the way that you can actually control how LUNs get unmasked to hosts. So in this case, when I allocate to the host group, I'm not unmasking. It's just a database. It's just database metadata. So I'll get a handle to my VM host. This is where I'm going to deploy register the LUN. So register SC storage logical unit actually does the unmasking work. And this is what's going to create the masking set, add the initiators, add the targets. And then in disk manager, you'll see a disk that hasn't been initialized yet. Okay, so there's a few pieces that I need to add that are not completely handled through VMM, which is essentially creating the folder structure that I'm going to use, where I'm going to place the VM itself. Just because I'm doing this in a very specific way, as opposed to just just creating a VM, which VMM can handle. This I need to set it up in a particular way. So the UNC path I'm going to use actually is the full server name. It's on I know it's going to the V volume VMs, and then under the template name, I'm going to create a LUN1, right? So that's essentially where I'm going to do a folder mount point, or folder mount point to that LUN itself. Okay, so mount SC storage disk will take the LUN, and now it's going to initialize the disk, partition it, format it, and give it a mount path, which is the remote local path that I just mentioned before. So this is all set up just to get to the VM deployment piece. So I'm just setting this up, and then I'm going to run through a actual VM creation. Okay. All right, so I need an OS. I need a virtual disk. So I'm just pulling something. I'm going to pull something from the library. I'm going to place it in this location. Sorry, I'm pulling something from the library, which I'll then place with the VM as I deploy. Now, I'm going to do this through a temporary template. And so just so you know, the reason why I'm using a temporary template is because I want to use the new feature in SP1 is deploying VMs from a VM configuration. So a VM configuration is essentially a property bag that you can use. You fill it up with all the information that you need on how you're going to deploy the VM, and then you pass that to the new SC virtual machine commandlet. So previous to this, you had to either pass a template or some other information, but all of the customization was done in a really long parameter set of parameters in a parameter set. This way, it actually simplifies it by doing this all in a VM config, and then you pass it into the new VM commandlet. But to get the VM config, you have to start from a template. So I'll create a temporary template, just pass in some information on the OS, memory size. Okay, so now I'm going to generate the config from the template. For that config, I'm going to tell it to deploy on VM host, this particular VM host, in this particular location. Okay, so this is the host and the location where the VM is going to get created. And then I update the configuration, runs through some placement checks that it needs to run through. Now, in this case, I'm going to put the VHD configuration. We'll use the network. I'm just going to do a normal network copy, and I'm going to give the file a file name. Okay, so I'll just finish that creation here. So let me scroll up here. All right, so I've got my VM created, MMS demo template, and it's under all hosts. And now what I'm going to do, so assume that you've customized this VHD or this VM now. I'm going to grab an instance of my library. So I'm going to get the library share. And now I'm going to create, this template that I'm creating is the one that I'm actually going to use for rapid provisioning. So I'm using new SC VM template, and I'm just passing in the VM that I just created, right? And so the key piece to note here is that when I kick this operation off, and this is where the SAN integration comes in. So right now it says transferring using, you can see it, right? Yeah, transferring using LAN. We recognize that I better not say anything before I lie to you. Well, it should have switched to SAN. Let me see if I can refresh. There we go. Okay, minor UI glitch. So we recognize that this VM actually is deployed on the LUN that we manage. And then we can do SAN transfer in this case. So we recognize that the SAN transfer is possible. We switch the deployment type. And then what we're essentially doing is masking the VM or the LUN from the host, which contains the VM and VHD and config. And then we're going to present it to the library. We're going to put the template under the library server and under the library share. And now I can use that VM template for deployment of VMs using rapid provisioning. So I'm going to switch over to the library view and then VM templates. And I've essentially got MMS demo template, and this is a SAN copy capable template. Okay. Now, the next piece I'd like to do. So this template I know I'm going to use for VDI, and let's say I want to create 1,000 instances. So I know that the LUN is only going to support, let's say, 256. So the piece that I have to do is if I go back to Fabric, scroll down and go to Classification and Pools. So this is the LUN that contains that template. MMS demo template, I go to properties. So I can do an associated logical units. In this case, these are all of the LUNs that are associated to a particular LUN that I'll use for rapid provisioning. So I've already got one set up, which is my scale template, and it's got 4 LUNs created from that, right? And so these are the associated. All right, yep. So if you see it on here. So this is the bottom piece in the details pane. These are all the associated LUNs of my scale template. So I can start provisioning VMs from that. So I've already done that just to save a little bit of time. So if I just look for scale. Come on. So I've got 3 VMs already deployed using rapid provisioning. So what I'm going to do now is then, since I know I'm going to use this for VDI, let me just switch back here. Let me continue with the script, and then it'll launch a web page that I want to show you. Shouldn't take this long. Okay, so I'm logging into the RDSH session that I've deployed on one of my machines. Okay, so how many of you are using RDS in Windows Server 2012? Have any of you actually used it? So what I have here, let me move the mouse a second here. What I have here is what's called a collection. Collection is used through the broker for, this is in a pooled VM case. Any users logging into the broker can then get a VM from that collection, right? So obviously you want to be able to add VMs to the collection. So what I'm going to do now is switch over to that box. So I've got the RDS session set up, RDSH environment set up here. I've got my collection called MMS RD Web. And I've already got one VM in here. So what I'm going to do now, you can do this both in the UI and CLI, is to, I'm going to call it, okay, never mind that. So I'll just, from here, I'm going to go to tasks, add the virtual desktop. So it's going to recognize all of the VMs that I've got deployed there that are not part of the desktop. So these were all the rapidly provisioned VMs that are now part of the host, or part of the collection of hosts that you can use for RDS and RDSH, and then you can add those VMs to your collection. Right now, they don't get automatically added. That's something that I've been engaged with the team to see if there's a way of automatically adding these VMs provisioned outside of RDSH. Otherwise, if RDSH was the one actually provisioning VMs, with the RDS connector that ships with SP1, you'll actually be able to use VMM provisioning to get new VMs into that collection, and they'll automatically show up. But in this case, since I created them out of band, I just get to add them manually. Okay. So let me switch back to this demo here. All right. So now I can go off and clean up everything I did, and you know what, I'm not going to spend time on that. So just to recap what I've done, so what I did for this demo, I created a VM, and you can customize it. You can take that VM, make a template out of it that uses SAN transfer. Now that's a SAN copy capable VM because you can clone the LUNs, and it's already got a VHD that's sysprep that you can use for VM deployments. I extended the capacity or the ability to create many VMs from the particular template by allocating clones to the LUN that contains that VHD, and now you can spread 1,000, for example, 1,000 VMs through all of those associated clones. Okay? So before I get into this last scenario around fabric provisioning, any questions so far? Anything top of mind for anybody? Yes? So I thought I had. No, actually, you can do that through VMM. So this particular script here is actually using the iSCSI target as a demo. It doesn't support cloning, so I had to do this manually. The reason why I have it is manually there. But the key piece is that I can associate existing LUNs that maybe I've done out of band using the set SE storage logical unit. Or if you want to do this in the UI, you switch over back to Fabric. So we start with the MMS demo template, right-click, properties, associated logical units. So I'm going to do some number. So, sorry, just so you know, after all these actions in the UI, all of our UI has a view script option, so you can click on view script, and you get to see the actual script that we're going to execute as part of this UI workflow. So the key piece to highlight here is that I'm using new SE storage logical unit, giving it some name, and then logical unit method is clone. So this is using cloning, not snapshots. And then I'm going to pass in the logical unit, the source logical unit that I'm using, and then I'm going to set that as a logical unit copy source for the new LUN. That's how you would create it. Thank you. All right. So the last piece I'll show is, well, first I'll talk about something that we don't do in VMM. And so Windows Server 2012 introduces virtual fiber channel support inside of VM. So you can now have a VM configured with synthetic device that's a virtual HBA. These virtual HBAs, like any HBA, get worldwide port names and worldwide node names. Those port names can be added to a zone, and you can then present storage from an array to that VM directly. These are not pass-through disks. These are not the typical pass-through disks that you would expose to a host. These are actually LUNs that get exposed directly to the VM. Now, in SP1, we try to get this feature in for SP1, but VMM today is only compatible with VMs that have virtual HBAs configured on them. So we will recognize these VMs, we'll start them, we'll stop them, we'll live migrate them with no issues. We've done the work to make sure that we don't break these VMs, but you will not be able to see any of the virtual HBA information. You won't see the SAN information. You can't get the worldwide port names through VMM. It's an unfortunate miss, but that's just where we are today with SP1. You can obviously use Hyper-V to manage these VMs, and then obviously they get imported into VMM. So one of the questions that we get now, or one of the concerns we get from some customers, is that now that we've made VMs so easy to deploy, you can deploy hundreds, in a matter of minutes. That's all great. But if you want to deploy one of these things, obviously in production, you're not going to have hundreds or thousands per host. You might have a few, because you're running tier 1 applications. These are meant for SQL clusters or large-scale clusters and environments that need a lot of RAM, a lot of CPU, and a lot of storage. So you need the performance into tier 1 application. But customers and partners are coming to us and asking, well, that's production, but in the meantime, I've got to deploy a lot of VMs that have all of this virtual HBA information. So I can deploy them really fast, but I can't get storage to them because I've got to go out to the SAN admin, I've got to get a zone, a new zone, or modify a zone set, got to get a zone set activated. There's a lot of hurdles to go through to get that storage actually exposed to the VM. So one of the last time I'll show you today is how we can use something called pass-through that's supported in Windows Server. So I mentioned before, this is a slightly different picture for SMAPI, but I mentioned SMAPI before as being our interface to the storage. And this gives us access to all of the underlying storage providers. There's another piece of the API called pass-through. Pass-through, it's exposed in PowerShell and in WMI, and it essentially gives you a way of accessing the underlying provider for features that are not natively supported by storage management API. So for example, if you have, let's say, SMAPI supports functions 1 through 10. There's more, but for argument's sake, 10 functions. This particular provider supports functions 11, 12, and 13. So you really want to get to those to that functionality and maybe create a UI plugin. How many of you know about the UI plugin feature in Windows? In VMM? Okay, so in VMM now you can create these snap-ins or plugins, UI plugins, that actually light up some pretty cool scenarios. Then we're working with a lot of partners on doing this, and they're really simple to create. And it's something that even any customer can really create to help fill a gap. So the particular pass-through API now, I can get access to any storage, any SAN provider, NAS provider, more importantly, a fiber channel switch provider. So even though it's not supported by Windows, I can still get access to this. If you look at all of our NAS integration in SP1, that's actually going through pass-through. We're not depending on SM API for that feature set. It'd be nice to have it all native and be beautiful, but for now we are using pass-through. We're making it simple. We're abstracting the complexities, so it's managed the same like any other file server. But we took on the work of building the provider work. Okay, so the provider interface itself is part of the WMI v2 stack in SM API. It's a top-level class that works with a SIM session and SIM objects. Okay, and all you really need to all you need to pass in as part of the session is a provider name, some credentials, and the namespace you're working with. So I'm heading into a little bit more of an advanced demo, but I think it'll solidify once I actually run through the code and see what it actually is doing. Some of the high-level things that you can do through this interface, the methods that we support: create an instance, delete an instance. The really cool ones are around invoke method. So any method that's supported by that provider, you can invoke through this interface. You can also get any instance. So if I wanted to get all of the fans, right, on the array, you can, if it's modeled inside of the provider, you can get it through the enumerate instances or get an instance, et cetera. You can also get class information. So we're heavily leveraging standards-based management to be able to manage these devices in a very consistent way, even though it's not supported natively in SM API. So I'll give you one example. First, we'll start off with context. So when we start a new SIM session, you got to give it some information. Here's a provider, here's credentials, and here's the namespace you should be working in. So those are that information. You start the new session, and in the session, you tell it locally what namespace to go through. So this is the pass-through namespace. This is part of the setup. And then here, I'm just enumerating through classes. Right? If I wanted to, let's say, get an instance enumeration, really the only thing that I'm changing between these two is the enumerator classes to enumerate instances. Okay? So here I can enumerate instances of a storage pool. So here, for a storage pool, I get all the instances. So if you have 10 storage pools, you'll get all of that rich information. And like I mentioned before, the method invocation, a little bit meatier, but the key pieces to highlight is first, I need a config service. I'll show what that is in the demo itself. This configuration service is what I'm going to use to get the method that I'm going to invoke, right? And so the reason why I know this method, not through magic, I actually you can go through the standards documentation and see all the methods supported by the different devices or the different classes. So here I'm creating a LUN. So all I'm going to do now is give an element name, demo volume, element type, size, and what pool I'm going to use. If you notice from my previous demo, new SC storage logical unit, name, size, and pool. Okay, so very similar setup there. And then I just invoke the method. Right, so this is a synchronous call, and then when it comes back, I'll have a virtual disk or a LUN object. And then you can do other cool things with it. All right, so how do we do this for Fabric? Okay. I'm going to switch back to the PowerShell ISE. So in this particular demo, can you guys see this? So is the text okay? Yeah? All right. So I've got, I'm going to set up my connection information, password, name, and everything else. And in this case, it doesn't say here, but I'm using a Cisco provider. So this is let me ask the question before. How many of you are actually working with fiber channel devices and fiber channel fabrics today? Okay, and how many of you are actually using or want to use the virtual HBA feature in Windows, the synthetic fiber channel? Okay. So for those that, I'm going to, if there's any questions as I go through this, let me know for those that don't work with fiber channel. But I'm going to start with the Cisco provider. This is a proxy provider. Through their documentation, you know the namespace that you're working with. So the first set of instances I'm getting are what are called admin domains. In other language, this is called a fabric. Right? So the fabric contains a bunch of zones. So zone sets. Zone sets contain zones, and then in the zones you have members. So through a zone, you present targets to initiators. And this is a way of locking down who can see what on that fabric. So admin domain is the standard space name. I'm going to iterate through all of the fabric domains or admin domains or fabrics, I'm going to get one called dummy. So we created a small fabric on the switch called just dummy, and I'm going to get that particular instance. So then I'm going to enumerate for this particular fabric, I want to get the config service, right? So we know it's called zone service, and then that's where I'm going to get the configuration service from. So I'm just going to iterate through all those associated instances, and I'm going to get that configuration service. So now I'm going to get a zone. So I want to get a particular zone where I'm going to add a member, right? So you add members to zones, and then you activate the zone set, or essentially the database that contains all the zones and members. So I'm going to get an instance of that zone. And like before I mentioned, there's a method where you can create the logical unit. Here the method is create a zone membership setting data. So this is essentially adding a worldwide port name to the zone. So that's this last piece right here. So I go through some more information, and like I mentioned before, now to invoke the method, I'm going to give the worldwide port name. Obviously, this is not a real one, but for demo purposes, is good enough. And yep. So this is the member that I'm going to add to the zone, right? So I've got here the invoke method for the storage config service, the method that I want, and the parameters that I just set up, right? Essentially, the member of that zone. So after I've added it and it's complete successfully, I'm going to get the zone set, and then I'm going to first I got to enumerate the zone set instances, get a name. So it's called dummy active. That's just a database name that is going to get activated. I'm going to do another invoke method. Here, in this case, what I'm going to do is for this zone set, I'm going to activate, and then I'm done. Right. So let me show you the Cisco environment here. Let me refresh this. So this is the Cisco management environment. I've got this dummy zone. I've got a bunch of worldwide port names here, and if I switch back to my demo, the one you should look for. Hold on. There we go. CB, AB, CB. Right, that's the one that you should look for in the. You know what? Just in case. Okay, so yep, I'm going to execute this script. So, like I said, it's walking through everything we just mentioned. Activate zone set takes a little bit of time, so I don't need to wait for that to show what I've done. I'm going to switch back to the Cisco environment. I'm going to refresh the zone. So CC. Whoops. There you go. So I added the member, and the activation of zone set is required to actually make sure that the active zone set has this worldwide port name. Now the HBA can log in, and now you can start presenting storage to the initiator. Now, that initiator, let me switch back to VM. That initiator could be, for example, a host, a cluster. We support, in Fabric, if you go back to classification and pools, you can click on MMS demo template. Another part of this is what's called logical unit assignment. In this case, I've already assigned this LUN to a particular IQN or in iSCSI. This would also show worldwide port names. And in the registry, you can flip a bit to actually add worldwide port names to this list, right? Sorry, as for fabrics. And so, since this is unmasking, so once I've already zoned it, now the host and the array can see each other. Now I can create a masking set or expose the LUN to that host using the CLI for Fiber Channel. If it was iSCSI, you can use the UI. So this would work for a host. So you can right-click, go to the host properties, add the storage, or you can do it for a VM. So that's how you would automate the provisioning of storage in the case of you're using Fiber Channel with Hyper-V and virtual HBAs. So I know that was a little bit more advanced demo, but I just wanted to show the power of what's in the platform. And essentially all the capabilities that VMM is using is also available to all of you if you start seeing the benefits and taking the time. And it's a lot of work that you can do through SM API to really unlock any scenario that you want. And now you can just all do it through a central console and central API. So I'm going to skip through the. So wrapping up here, I wanted to just highlight a few of the features that we support for Windows Server. So I'm taking a little bit of a shift from the scenarios and just talking about the features and where we stand with different capabilities. So like I mentioned before, Windows introduces storage spaces, and it's the ability to group disks into pools. And from a VMM perspective, we don't know about it. We don't manage it. We don't create virtual disks. We don't create pools. That's a general case, but for spaces, we don't create pools. We don't have any management of spaces today. So just so you're aware that it's a capability in Windows Server, but we simply don't have that today in VMM. Offloaded data transfer. Another great feature in Windows. Anybody know about offloaded data transfer, ODX? Okay, for those of you that are familiar with VMware, I think that in their VAAI set of APIs, I think they call it full copy or fast copy. I don't know if anybody knows the... Okay. Anyways, it's essentially a way of moving data from point A to point B using the capabilities of the SAN. So you never actually have to move data over the network. Okay, so it's just leveraging the SAN capabilities itself, and it's something that's fully integrated into Windows. From a Hyper-V perspective, storage log migration takes advantage of ODX if it's available. Okay, VMM, however, does not. So it's an integration that we didn't do for SP1, and the reason for that is because we use bits, background intelligent transfer service. This transfer service essentially copies data for us from point A to point B, but it's not ODX aware. It doesn't use the copy file APIs on the platform. So any one of the transfer options in VMM today is not optimized. So I want to point that out today that it's not there today, but something that we're working on for a future release. Hyper-V Replica. How many of you are using Hyper-V Replica or know about it? Okay. So Hyper-V now supports the ability to replicate VMs from source to targets using built-in technologies. It's native in the platform now. VMM today does not have support for managing that. That's actually something that we're working on right now, but there's no way of enabling Hyper-V Replica for a host. There's no way of enabling protection for a VM so that it can start replicating. That's the best we have today, and I think I have a screenshot, yeah. Is that if you have a VM that is replicating, right? We will show you both VMs, okay? Be on separate hosts, obviously. We'll show you both VMs. The secondary VM or the replica VM is going to be in a stop state. And if you right-click on it, you can't do any actions. You can't start it, you can't stop it, you can't delete it, you can't do anything. But that's as far as we go with the integration. And we do pull in some Hyper-V replica information. So in this case, I put the VM into a warning stage, the replication into a bad state, and then I get the warnings. So you're at least able to see some of the health information, but you're not able to manage the Hyper-V replicas. VHDX, we have full support for VHDX. I know that's been a big ask from customers on supporting larger virtual disk sizes. So VHDX does bring that higher capacity. And from VMM, you can create them or you can have them in the library and deploy from them. So I want to finish up with standards-based management. So we do a lot of work around standards-based management. And SNIA is the standards body, the Storage Network Industry Association is a group that we work with. And SMI is Storage Management Initiative. And they're actually at MMS, booth 717. Please make sure you stop by and say hello. Get to know more about the standards and how we use it and how other partners are using it. So we do participate in a lot of plug fests. Also with the file server team, they do participate in SMP3 plug fests as well. So there's a lot of work that's done by us in the industry when it comes to standards-based management. The way that this all lays out, another picture, another way of looking at all the integration points is that with Windows Server and System Center in the middle, you've got support for all these types of providers. Today, the SMIS provider community is actually fairly big as far as companies that implement SMIS or use SMIS in their clients. So administrators can always use Windows Server, right? Like I said, you can use those APIs that are now native in the platform, or you can use the applications available today. Hosters and ISVs and people building some more advanced solutions can use Windows Server, can also go directly against those SMIS providers, okay? And if you guys are building any cool additions or solutions or value add on top of Windows Server, you also get the path to all the providers. So we have a pretty extensive list of partners. There's 2 pages here, so I wasn't able to cram it all into one. So we have all of the partners here. that we work with today. NetApp, EMC, HP, Hitachi on this slide, and Dell, and all of the different versions. So this is actually an ask from all of you to make sure that I include the version number. So I reached out to all the partners. Anybody that could tell me, I made sure to put it there. For example, I've got the NetApp C mode is in progress as far as getting their provider up. A lot of customers have been asking me about HP left-hand or Store Virtual, so that's up there as well. We got the Dell EqualLogic in here supported. That's coming June 2013. And then we've got a few others. Now, Microsoft is, oddly saying it's a partner of itself, but it's another group that built a provider. So we ship it, and now we support the SLD target as well. This is a huge customer ask that we've had for several years, and we delivered an SP1. So, is there somebody on this list that isn't there that you would like to see there? Anybody missing that you'd like to see managed by VMM? Say again? Store Simple. So, not right now. I'm not sure how we're going to do that integration right now. Okay, but yeah, that's not a partner that we're working with. So this slide deck, this wiki down here is actually available today. So you can get all of the list here. This is actually more complete than that list. So we'll have to update that site. This slide deck should be available either now or after the. Which company? Not sure about that one. So let's follow up afterwards. I'd like to know. Okay. All right. So in closing, this is a big thank you to all our partners, all our customers from the VMM team. We actually took this picture a few days before we shipped out to MMS on the one day that we get of sun in Seattle. So this it's not fake. This tree is actually there and beautiful, and everybody shows up for pictures. So we actually were able to get a good day and a good picture. So thank you for everything. Thank you for all your support. We really appreciate it. Any feedback, anything that you need from us. Obviously, we've got a big contingent of VMM people at MMS. There's 2 of the storage developers in the back room doing a MIT. And thank you very much. Please do fill out your surveys and have a great MMS.